Okay, it's the next morning, and I'm going to go ahead and weigh our banana starch samples today. So, overnight in the drying oven, those three filter papers labeled green, yellow, and brown have been drying out, and we got all the moisture out of the banana. So, we remember previously we tried to dissolve the starch out of the bananas. So now we've removed the water from the banana sample. So we took that pellet that was at the bottom of the test tube once we had centrifuged it. We took that pellet and we filtered it. That pellet was starch. Starch is a polymer of carbohydrates. It's a long chain of monosaccharides, of glucose monosaccharides, in fact, and it does not go through a filter paper. So first thing we need to do today is to get our step 22 number. So right here, step 22, mass of starch and filter paper. This is our last measurement for this lab, and it will be the last thing we do before we do the calculations. We'll do the calculations together. Okay, so here's our sample of green banana starch. And the filter paper and the banana starch together weigh 1.29 grams. So this would be the green. So thankfully that does weigh more than the filter paper alone, which was 1.23 grams. But as you can see, not much left after we evaporate the water out of the starch. Okay, let's go next to the brown banana sample. And it weighs, so it weighs 1.14 grams, so we're not showing any mass there, even though we can see that there is some mass. We're showing such a minimal amount of starch that it's not even showing up. And then for the yellow sample, again we're getting, must have been some moisture absorbed into our paper because we're getting same mass before and after here. So we're going to call it 1.27 grams for the yellow. So the green had a little more starch than the yellow or brown did. The yellow and brown had virtually none to speak of. I could actually see starch on the paper, but when you factor in the fact that we probably had a little humidity in the air, and that probably had changed the mass of our paper, and that we dried it out in the drying oven. All right, let's go ahead with our calculations then for our green banana sample. By the way, here's those numbers for step 22, 1.29 for the unripe banana, 1.14 for the overripe, 1.27 for the yellow. All right, the first calculation that we need to make, I'll put my data up here first for the mass of the starch plus filter paper. For the green unripe banana was 1.29 grams. And now right underneath that is the place on here for the mass of starch. So 1.29 minus 1.23. Remember, show your work in those boxes. Don't just show the answer. So it comes out to 0.06 grams of starch. So if we consider that the sample weighed 1.11 to start with, 0.06 over 1.11 times 100 gives us a value of, grab a calculator here, 5.4%, and I believe they wanted us to report to a whole number, so we'll say 5%. So the banana, the green banana, was 5% starch. We got our volume, banana extract volume here, and the concentration of the banana, of glucose in the banana extract was measured with the glucose strips. They're actually designed to be used with urine. If you have do a urine test if you're diabetic, and you can test your sugar content in your urine. But 100 milligrams per deciliter, we're going to calculate how many grams of glucose that comes out to be. So keep an eye on my factor label conversion here, starting with 100 milligrams over 1 deciliter. I'm going to change first the deciliter to liters. So I'm going to change, there are 10 deciliters in 1 liter. Deci, like 10 decimeters in a meter, 10 deciliters in a liter. And then I'm going to change that to milliliters. There are, in 1 liter, there's 1,000 milliliters. So if you see here what I'm doing, I'm getting deciliters and liters to cancel, and now we have our milligrams per milliliter. I want the total grams, not the milligrams. I'm going to take this times 1 gram for every 1,000 milligrams and cancel my milligrams. And now my final step is that the total volume that we measured was 17.19 milliliters, or 17.9 milliliters rather. And so that's going to cancel the milliliters, and we'll just have grams. So that would be the same math you would do with the yellow and brown bananas as well. I'm just doing it for the green banana. So now I take my calculator, clear it, 100 times 10 divided by 1,000 divided by 1,000 again for the milligram conversion, then times 17.9. So I'm getting 0.0179 grams of glucose. So the percent glucose in the banana, 0.0179 divided by 1.11 times 100 is 1.6%. And they want that reported to a whole number, so it's 2%. So our green banana is 2% glucose, 5% starch, and probably about 93% water, right? Because bananas are moist. So our total mass of carbohydrates is the 0.06 grams of starch plus the 0.0179 grams of glucose. So it's 0.0779 grams of starch, carbs. Starch is a carbohydrate, and so is glucose. Glucose is monosaccharides, it's single subunits, and starch is just long chains of that glucose subunit. Kilocalories from carbohydrates then, if you recall, it's 4 kilocalories for every gram of carbohydrate. So they are 4 kilocalories per gram. It's that little bitty piece of banana. Remember, we just had a little gram of banana, and it was a very small piece of banana. But the carbs in that little piece of banana is 0.31. So a little under a third of a calorie for eating that little tiny bite of banana. Okay, so I'm going to wrap this video up here. I've shown you how to do the math for the green banana, and now you can take that same approach to finding the math for the overripe and the yellow banana. And then you can decide if your hypothesis was correct or not.